Hello, we are on part 2 of the air pressure lab and scientific method. And as you recall, we have gone through questions 1, 2, and 3. And the most difficult part of the lab, and we'll deal with this in part 2, is question 4, which is on the scientific method and the application of looking at air pressure data from weather balloons to learn how to use the scientific method to actually understand the differences in air pressure and why we have them between two cities, one in Lincoln, Illinois, and one in Key West, Florida. So your first city is in Lincoln, Illinois, and there's the weather balloon data, and your second city is in Key West, Florida. The key to remember between these two cities is that these cities were chosen because obviously Key West, Florida is much warmer, and because of that warmth, air is going to be behaving differently relative to how it expands or compresses in that warmth. And that will ultimately affect air pressure, surface, and readings, and why there will be a difference between, and a pressure gradient between Key West, Florida and uh, Lincoln, Illinois. So I take you through the scientific method, and you really need to understand first and go through this video to understand the steps of the scientific method. And you read this video or watch this short video there that walks you through understanding the steps of the scientific method. And then to really understand, I would advise you to go through this third video again. I know you've went through it maybe earlier in the lab. Really watch and go pay close attention to what happens to air as it's heated or cooled, and what happens to the air pressure as it expands or compresses in relation to temperature differences in the air. That will be key for you to understanding. So when you go back down now to question 4, which is the largest part of the assignment, this is just an introduction here of what you'll be trying to accomplish and some of the concepts you'll be looking at. And you should really know those concepts after you watch those videos. Question 4 breaks down into 4 parts. Question 1, question 2, question 3, and question 4. They are basically the steps of the scientific method. After you've done your reading and watched the videos, you're to make an observation. In general, what would you expect to find when you compare 500 millibar and 850 millibar readings, which are air pressure readings above the Earth's surface, relative to, will they be higher or lower in altitude? And remember, so when you're looking at these air pressure surfaces, what we're looking at is we're specifically trying to understand in question 4 is, would you expect the 500 millibar or the 850 millibar heights to be higher or lower, understanding that it is obviously much cooler in Lincoln, Illinois, and much warmer? What will that warmth cause the 500 millibar heights to do in Key West at the 500 and 850 millibar heights? So that's the first part of the assignment. The second part of the assignment is you need to make a statement of hypothesis. A hypothesis is a general statement of what you think you expect to find once you understand and make an observation and make the connection between air temperature and the height of the 500 millibar and 850 millibar heights. You then come down and make a hypothesis, and you should understand how to make a hypothesis after you watch the video on the scientific method, but it has to be written in a way that is very specifically testable, that you can prove it as true or false. So the correct way of stating a hypothesis is often with a null hypothesis, and that's where you're basically comparing and you're making an observation that you may or may not agree with, but a null hypothesis is where you state that you have two groups or two classes or two things you want to compare, and you believe that there are no differences between them. And then you're going to actually make observations to collect data to verify whether that is a true or false statement. So for our example, I pretty much write your null hypothesis for you, and all you're required to do is to fill in this blank right here. Air temperature has blank impact on surface and upper level air temperature readings between Key West, Florida and Lincoln, Illinois. And you should very clearly, all you have to do there is either write has no difference, has no impact, or has major impacts on surface and upper level air pressure readings. Remember that this is a null hypothesis, and we want to test this, so by reading the statement, it should be very clear of what the word is. You should be able to plug in there. After you make a hypothesis, then you go out there and actually collect data. And you go out there and collect data, and I want you to look at the 850 and 500 millibar heights. To do that, all you have to do is go back to the charts, and for each city, you have to find Lincoln, Illinois, and find the 850 millibar reading, which is right there, and find the altitude, which is listed right there. Then you have to go in and write down the 500 millibar height, which is right there, and write down the altitude. That was for Lincoln. Then you go down and do the same thing for Key West, Florida. And the Key West, Florida, the 850 millibar height is right there, and the 500 millibar height is right here. I then want you, and there's the altitude, by the way, is right there. I then want you to compare the heights, and they really are telling you whether the air is compressing or expanding. Expanding air causes lower surface air pressure. Compressing air has, cooler compressing air has higher air pressure. So warmer air should be causing the 500 millibar and 850 millibar heights to expand and be at higher altitudes, which means the surface pressure would be lower on the ground. And obviously Lincoln, Illinois and Key West, Florida are very different environments. I actually asked you to make a graph, and I actually have already created the spreadsheet for the numbers. I've actually already recorded them for you. And all you're required to do is make a graph. So if you click on the actual Excel spreadsheet there, you'll actually see a file opening up, and you could put it down here at the bottom, and it'll actually open up, and you should see an Excel spreadsheet opening up, and I've already got it started for you. And you should see Excel opening up, and I will want you to actually compare the data to actually test and see, are the two heights the same. So here is an Excel spreadsheet opening up. I'm going to try to maximize the window here for you. I'm going to enable editing so we can actually do some quick analysis. And when you see the numbers there, here is the 850 millibar heights for Lincoln, Illinois and Key West. Here's the 500 millibar heights. Notice that the numbers are indeed different, and the numbers are consistently higher in Key West, Florida than they are in Illinois. This, in fact, doesn't mean that there is a pressure gradient between Key West, Florida and Lincoln, Illinois. And all I would ask for you to do is to make a quick spreadsheet as you highlight the cells, and you would go to the insert menu, and you could make a quick chart. And there's a variety of charts you could pick from, and I'm going to pick a 2D chart here. And what it shows you here is that if you look at the chart here, notice that very subtly at the 500 millibar and the 850 millibar heights that the Key West readings are indeed slightly higher in altitude. This means, for example, that at the 500 millibar height you could see the air is expanding, and in Lincoln, Illinois the air is compressing. This does verify that in fact a pressure gradient does exist. You would save into a file, save as, and save that spreadsheet and save it as a separate file and attach that with your graph so you could verify that in fact you do have, you did do some analysis on step 3. On step 4 then, after you've looked at the data, and obviously the 850 millibar and 500 millibar heights are indeed different, all you would need to do is look at the charts. Do you accept or reject your original null hypothesis? Remember, your null hypothesis should have stated something along the lines that, did you think that there was going to be no difference, or did you expect that there would be differences? The null hypothesis should have been stated that, if you recall in step 2 when you stated your null hypothesis, more than likely most of you should have answered air temperature has no impact. Well, obviously from your graphs, did they indicate there was an impact? If you think there was an impact, you would basically conclude in step 4 that you would reject your null hypothesis, because in fact you did see a difference, that the warmer air temperatures did have an influence on creating pressure gradients and air pressure readings in Key West versus Lincoln. If the graphs were perfectly lined up and they were exactly the same altitudes, that mean in fact you would accept your null hypothesis that there was no impact. So it should be very clear of which answer you would accept here. So in part 4, it's just simply, do you accept or reject your hypothesis based on your observations from the graphs in part 3. So that walks you through how to use the scientific method, and should help you understand part 4 a little bit better, of how to use air pressure readings in the scientific method to verify that in fact air temperature is directly related to causing air either to expand or compress, and this air expanding or compressing is what creates pressure gradients and winds to move around the Earth.